Morning. Today I'm going to work through how to find the area and perimeter of both a circle and a trapezium. Right, this question's caused a bit of trouble with the trapezium part because it hasn't been labelled very well at all. But before we get to that, let's first look at the circle. There should be two formulas that you can remember from year 8, but that was a while back, and if you're like me, you just can't remember anything. I can't remember anything from 10 minutes ago. Okay, the perimeter of the circle is called the circumference, so we're going to call that C. Circumference is equal to pi. I can't be bothered to get the symbol up, so I hope you know what I mean when I say pi, that funny symbol, right? Circumference is pi times diameter. That's where pi actually comes from. A lot of people, they take for granted what pi is. If you take a circle, any size, doesn't matter if it's like a circle that's the size of a penny piece, or if it's the circle that's like, I don't know, like the shadow of the earth, like something just so massive. If you take the circumference of a circle and divide it by the diameter, you'll always get 3.1415 blah blah blah. That's where pi comes from. It's the relationship between the circumference and the diameter. Okay, so let's say for example, right, you were asked to find the circumference of a circle with a radius of 10. Alright? Radius is the distance from the center of the circle out to the edge. So if you can imagine like a radar screen in like an airport or something, you're going around like blah blah blah, or like the arm on a clock or something, that's the radius, okay? The radius is half the diameter. So you can adapt that formula, because if you think that the diameter is double the radius, so one diameter is like 2 radii, you can change that formula to be the circumference is pi times 2 times r. Pi times 2 radii, which is the same as pi times diameter, okay? Or you could just double the radius to get the diameter, but you can see that that's doing exactly the same thing. So, like I said, let's say a radius of 10. So C equals pi times 2 times 10. Oh, that's not 10. So C equals pi times 20. Okay, now you get your scientific calculator out. If you're at work at home on the computer, if you bring up the Windows calculator and go to View, Scientific, you can get one up. So 20 times pi is 62.83 to 2 decimal places. 62.83. Pay attention to units as well. In the project, it gives you them in centimeters. So here, that would be centimeters. That was the project. So that's the circumference. The area of a circle is a different equation. It's similar, but it's different. The area of a circle is pi times the radius squared. So, we always said the radius was 10, so area is pi times 10 squared. Okay, the most common place people go wrong when they do this, they see the formula area equals pi r squared, right? And they do pi times r first and then square it. You can't do that. If the equation was that instead, you follow BIDMAS, so you do brackets, then indices and everything. If it was like that, then you'd do pi times r first and afterwards square it, but that's not the equation. When you follow BIDMAS, you do brackets first, then indices. So you take care of the power bit first, you do the r squared bit first, and then times by pi. Gives you two totally different answers. Of course, only one of them can be correct. So pi times 10 squared is 100. Area equals, well, if we take pi as roughly 3.14 and we times that by 100, we're going to get 314 centimeters squared. But let's just double check that. So 100 times pi, yeah, 3.1415, round that to 16. for the purpose of 2 decimal places, just to be nice and accurate. There we go. Yeah, area is 314.16 centimeters squared. So there's 2 important equations you need there. Area and circumference. So the circumference is pi times diameter, and the area is pi times radius squared. And you do the radius squared bit first, and then times by pi. Very important, or you'll get a wrong answer. Just out of curiosity, let's see what happens if we actually do that the wrong way around. So we do pi times radius first. So we get pi. Where's times gone? Times 10 is our radius, which gives us that, and then we square it. Yeah, we get 986. So it's 3 times too much, roughly. So yeah, you can see you get 2 very different answers if you do that wrong. So there we go. That is how you find the circumference and area of a circle. Right, now, trapezium time. This question has caused a lot of headaches because it's not labelled properly. It assumes stuff. And if there's one thing in maths that you should never do, it's assume anything. This is called an isosceles trapezium. The reason it's called that is if you think what an isosceles triangle is, it's a triangle where 2 sides are the same. But I was saying before, you should never assume anything in maths. Just because something looks like it's something doesn't mean that it actually is something. That's really important. Just because lines look like they're parallel, it doesn't mean they are. You need the question to actually tell you that, and it will either tell you that in writing or it will use signs. These aren't the signs used to mark parallel lines. These show that these 2 sides are the same length. In the project, there should have been sides like this. It should have told you that those 2 sides are the same, but it didn't. Which isn't cool as far as I'm concerned, but whatever. Let's just roll with it. So let's, just like I've been doing in the past, let's pick some similar numbers. So we've got the length of our top side, and we've got the length of the bottom side. I'm just going to make up some numbers and we'll work through it. Okay, so let's make that 12. Let's make this 15. No, let's make it 16 actually. The height we shall make 5. Don't know why, just we will. That's the height. And the length of the sides, which funnily enough we won't need for the area, but we will for the perimeter. We'll make that, will have to be more than 5, won't it? We get 7. Okay, now, 2 things we need to find. We need to find the area and we need to find the perimeter. Let's find the perimeter first, because that's going to be easier. Because that's just adding that side, that side, that side, and that side together. Ignoring the height. That's not a length of a side, that's just the distance from there to there. So we have 12 plus 16 plus 7 plus another 7. So the perimeter is 12 plus 7 plus 16 plus 7. So that's like 12 plus 16 plus 14. 16 and 14 is 30, plus another 12, that gives us 42. So the perimeter is 42, I don't know, centimetres, assuming these dimensions are in centimetres. Okay, area. The area of a trapezium. The formula for the area of a trapezium is a half a plus b h. A half of a plus b times h, where this is a, this is b, and h is height. So the area is a half of 12 plus 16 times 5. So area is a half of 12 plus 16 is 28 times 5. You could times by 5 first or times by a half first, it doesn't matter, but let's just times by a half first. So a half of 28 is 14, times that by 5, so the area is 70 centimeters squared. So we've figured out the area of that trapezium, and we've figured out the perimeter. If you'll know what I'm on about now. If you get confused and I say this, don't worry, it doesn't apply to you. If what I'm saying makes sense, it means that you haven't assumed that these sides are the same, and you've broken this up into a Pythagoras problem, which is impressive, by the way, that you've noticed that, whereby you've turned the trapezium into a rectangle and two right-angled triangles by drawing these lines in. Whoops. And those lines are the height, and you worked on the assumption that that length is 12, this length plus this length are unknown, but added together they must make 4 because of the difference between 60 and 2. You worked it through, you got some answers, and I believe on the first project one you found that that side was actually flat. Listen, if you've done that, that's great. That's amazing. You're not going to get marked wrong, even though you're going to get different answers to someone else. Because as far as I'm concerned, you're actually more correct, because you have noticed that it doesn't tell you that it's an isosceles trapezium, and you've actually demonstrated a wider range of skills. You don't get extra marks, but you're not going to lose any marks. Likewise, if you do it the method I've just showed you, by actually going, okay, it looks like they were supposed to say that these sides were equal, that's also perfectly fine. They're both fine. Alright, so that's how you find circumference and area of a circle, and that's how you find perimeter and area of an isosceles trapezium. Good luck with that.